Good morning, friends. In this lecture, we will see some more examples on Laplace transform. So before that, I will just repeat whatever we have studied in the last lecture. So up to now, about Laplace transform, we have seen its definition of Laplace transform for given function ft. Laplace of ft, L of ft equal to f bar s is equal to integral 0 to infinity e raised to minus st ft dt. Then using this definition, we have seen some results, standard results, that is Laplace of e raised to at is 1 upon s minus a, Laplace of 1 is equal to 1 upon s, Laplace of sin at is equal to a upon s square plus a square, Laplace of cos at equal to s upon s square plus a square, Laplace of sin hyperbolic at, that is a upon s square minus a square, Laplace of cos hyperbolic at, s upon s square minus a square, Laplace of t raised to n equal to n factorial divided by s raised to n plus 1. So these are the results which we have proved by using the definition of Laplace transform. So we have seen some examples also. Continuing with the same, now we will see this type of example using the fundamental definition, that is integral 0 to infinity e raised to minus st ft dt. Using the fundamental definition, find Laplace of ft, where the function is given in terms of this 0 to 5 and greater than 5, in terms of the intervals. This 0 to 5, the function is, value of the function is 3, and for 5 to infinity, the value of the function is 0. So we start like this. By definition of Laplace transform, we have L of ft equal to integral 0 to infinity e raised to minus st ft dt, that is, this 0 to infinity we divide into two parts as we have seen in the properties of definite integral. So 0 to infinity, it is divided 0 to 5 and 5 to infinity. So Laplace of this ft is equal to this one, integral 0 to 5 e raised to minus st, but when the function is defined in the interval 0 to 5, its value is 3, so into 3 dt plus integral 5 to infinity, integral 5 to infinity e raised to minus st, and for t greater than 5, that is 5 to infinity, the value of the function is 0, and therefore into 0 dt. So this whole term becomes 0. Only we have to evaluate this integration. So here 3 is a constant, 3, and integration of e raised to minus st with respect to t, that is e raised to minus st divided by minus s. The limits are 0 and 5. So this minus s is also constant as far as t is concerned. So minus 3 by s, we take it out, e raised to minus 5s minus e raised to 0. E raised to 0 is 1. So this minus and this minus becomes plus. So I will just interchange this 3 by s into 1 minus e raised to minus 5s. That is the final answer. Next example is ft equal to t minus a bracket cube when t is greater than a, and it is equal to 0 when t lying between 0 and a. So by using same starting, by using definition of LT, we have Laplace of ft equal to integral 0 to infinity e raised to minus st ft dt. Now this 0 to infinity is divided into 0 to a and a to infinity. So here it is reversed as compared with the first example. No problem. We take this as first and this as second. So e raised to minus st into The value of the function is 0 when t lying between 0 to a. So e raised to minus st into 0 dt is equal to integral a to infinity. For t greater than a, it is a to infinity e raised to minus st into t minus a bracket cube dt. T minus a bracket cube dt. Now we use the value of the this integration is 0. For this we use generalized by part rule. By part rule you have seen. Generalized by part rule is like this. I will write here generalized by part rule. Generalized by part rule is like this. Sorry. Integral u v dx is equal to u v1 minus u dash v2 plus u double dash v3 minus and so on. So this is called as generalized by part rule. Generalized by part rule. By part rule. Where these suffixes 1, 2, 3, these suffixes indicates the integrations, and this dashes indicates the derivative. So see here, t minus a bracket cube is u and e raised to minus st is v. U into v1. v1 is integration of e raised to minus st. So e raised to minus st by minus s, then minus this u dash. U dash means derivative of t minus a bracket cube, that is 3 into t minus a bracket square e raised to minus st divided by s square, then plus, how this comes, integration of e raised to minus st by minus s, that is e raised to minus st by minus s into minus s, that is s square, plus again the derivative of this 6 into t minus a and integration of this e raised to minus st divided by s square. It's a integration. So e raised to minus st s square into minus s, that is minus s cube, minus again the derivative of 6 into t minus a with respect to t, that is 6 e raised to minus st divided by s raised to 4. 6 into so this is the integration a to and the limits are a and infinity. So this is equal to, the value of this is, the value of this is, when we take the upper limit e raised to minus infinity is 0, 0, 0, 0. So 0 minus, if we put t is equal to a, then this is t minus a, that is a minus a 0, a minus a 0, a minus a 0, and this one is 6 into e raised to minus as divided by s raised to 4. So minus minus becomes plus. So this one is your answer. Next example is ft equal to cos t, t lying between 0 and 2 pi, and when t is greater than 2 pi, the value of cos t is the value of ft is 0. Again the starting step is same. By definition of lt, we have Laplace of ft equal to integral 0 to infinity e raised to minus st ft dt. Again the same thing, 0 to 2 pi and 2 pi to infinity. So in the interval 0 to 2 pi, the value of the function is cos t. So e raised to minus st cos t dt into integral 2 pi to infinity e raised to minus st and into 0. The value of the function is 0. So this integration becomes 0. Only we have to evaluate this integration. So to evaluate this integration, use the formula is integral e raised to ax cos of bx plus c dx is equal to e raised to ax divided by a square plus b square into bracket a cos bx plus c plus b sin bx plus c. So if you compare this with this e raised to minus st into cos t, your a is minus s and b is 1, c is 0. A is minus s, b is 1, c is 0. So using the same formula, we can get this e raised to minus st a square, that is minus s bracket square plus b square plus 1 square into bracket a cos of bx plus c. A is minus s, cos of b is 1 t plus c is 0. So minus s cos t plus b is 1 into sine of bx plus c, that is sin t, and the limits are 0 and 2 pi. So if we put the upper limit, that is t is equal to 2 pi, then the value is e raised to minus 2 pi s divided by s square plus 1 minus s into cos of 2 pi. Cos of 2 pi is 1, so minus s into 1, that is minus s, plus 1 into sine of 2 pi. Sine of 2 pi is 0, and therefore the value is 0, minus the lower limit e raised to 0. E raised to 0 is 1 upon s square plus 1 into bracket when t is 0, cos 0 is 1, so minus s, when t is 0, sin 0 is 0, and therefore the value is 0, and therefore the after simplification, the final answer is s upon s square plus 1 into bracket 1 minus e raised to minus 2 pi s. Next example, ft equal to sine 2t when t lying between 0 and 2 pi, when t lying between 0 and 2 pi, and it is equal to 0 when t is greater than pi. So by definition of lt, again we have Laplace of ft is integral 0 to infinity e raised to minus st ft dt, that is 0 to pi. In the interval 0 to pi, the value of the function is sine 2t, so e raised to minus st into sine 2t dt plus integral pi to infinity e raised to minus st into 0 dt. So this becomes e raised to minus st. Again the same formula is given here. Same formula means here instead of cos, in the last example it was cos, here it is sine. E raised to x sine of bx plus c dx is equal to e raised to x divided by a square plus b square, a sine of bx plus c minus b cos of bx plus c. This one is the formula. So by using the formula, here a is, what is a? E raised to ax, a is minus s, x is t, e raised to as, and b is 2, c is 0, b is 2. So putting these values, we are getting e raised to minus st into divided by minus s bracket square plus 2 square. This is minus s bracket square plus 2 square into bracket a is minus s, a sine of bx plus c, that is minus s sine 2t minus b cos of bx plus c minus 2 cos 2t. Then again the we put the limits, upper limit first. So e raised to minus pi s, upper limit is pi, e raised to minus pi s divided by s square plus 4 minus s sine 2 pi is 0 minus 2 cos 2 pi is 1 minus 2 into 1 minus the lower limit e raised to 0 means 1 upon s square plus 4 minus s sine 0 is 0 and cos 0 is 1. So minus 2 into 1. After simplification, the value comes out to be 2 upon s square plus 4 into bracket 1 minus e raised to minus pi s. The next example, combination of these two, that is sine and cos. Ft is equal to cos t when t lying between 0 and pi, and is equal to sine t when t is greater than pi or pi is less than t. So again we start with the same step. By definition of LT, we have Laplace of ft equal to integral 0 to infinity e raised to minus st ft dt, that is integral 0 to pi and pi to infinity. So in the interval 0 to pi, the value of the function is cos t, and pi to infinity, the value of the function is sin t. So here we have to evaluate both the integrals e raised to minus st by using the same formula. Both the formulae that we have seen in the last two examples, we have to use these two formulas. E raised to minus st minus s square plus 1 square minus s cos t plus sin t, the limits are 0 and pi, plus e raised to minus st minus s bracket square plus 1 square into bracket minus s sin t minus cos t, the limits are pi and infinity. Again put this upper limit first, e raised to minus pi s upon s square plus 1 minus s into cos pi is minus 1 and sin pi 0 plus 0 minus the lower limit minus 1 upon e raised to 0 is 1 upon s square plus 1 minus s into 1 cos 0 is 1 sin 0 is 0. Then for this put first infinity, e raised to minus infinity is 0, and therefore the whole thing is 0 because this one is the multiplying factor. Then if we put minus plus 0 minus if we put t is equal to pi, then e raised to minus pi s upon s square plus 1 into bracket minus s into 0 sin pi is 0 minus cos pi is minus 1. So minus into bracket minus 1. So after the simplification, we will get the final answer as 1 upon s square plus 1 into bracket s plus s minus 1 e raised to minus pi s. If you are not able to do this, leave the answer here only. But do not make any mistake in writing the last step. Otherwise, you will lose the marks. Then some of the examples are like this. Find simple examples which are useful for your this test, and if the final exam is conducted in terms of this Google form or online mode, then also these are the examples which you can solve for the exam. So Laplace of e raised to 1 minus t, Laplace of e raised to 1 minus t means e raised to, by law of indices, e into e raised to minus t. So e is a constant, Laplace of e raised to minus t, e upon s plus 1. Second one is Laplace of e raised to 2 plus 3t, that is Laplace of e square into e raised to 3t. Again law of indices, e square Laplace of e raised to 3t, e square divided by s minus 3. Laplace of cos hyperbolic 4t, direct formula s upon s square minus a square. A is 4. Laplace of sine 2t minus cos 2t bracket square. Just square this. Sine square 2t plus cos square 2t minus 2 sine 2t cos 2t. But minus 2 sine 2t cos 2t is sine 4t, and sine square 2t plus cos square 2t is 1. So 1 minus sine 4t. Laplace of 1 minus sine 4t. That is Laplace of 1 minus Laplace of sine 4t. 1 upon s minus 4 upon s square plus 1. Then Laplace of sine square 3t, that is Laplace of sine square. Sine square is 1 minus cos 6t divided by 2, half Laplace of 1 minus half Laplace of cos 6t, that is 1 upon 2s minus s upon 2 into bracket s square plus 36. And the last example, Laplace of cos square 2bt, that is half Laplace of 1 plus cos 4bt, half into 1 upon s plus s upon s square plus 16b square. See here 4b is a constant, so its square, that is 16b square. So these are the examples for which are useful for your exam, and try to solve similar type of examples. Here it is cos square 2bt, you can take cos square 6t, cos square 3pt, like this. Cos square 2pt. You can interchange. You can change your constants as well as your this cos square. Instead of cos square, it should be cos cube also. Cos, you can have the formula for cos cube, you can have the formula for sine cube. So make the corresponding changes and try to form your own examples, make your own examples and solve at home. So and if you are having any difficulty, please ask at any time. You can send your difficulties on my WhatsApp, and I will then go through that and try to solve your problem. So for today it is sufficient. Thank you very much.